the dawn of the 21st century, space agencies in Europe and America began making plans to land the first humans on Mars. But manned missions to the Red Planet have been proposed before. For some, Mars holds the answers to mankind's future in space. Others say Mars is too far, too dangerous, and too expensive for humans to explore. And in a world torn by troubles, some say there is no need, or will, for mankind to reach into space anymore. More than 30 years after the last Apollo astronaut walked on the moon, the American manned space program seems to have lost its way, unable to reach beyond even low Earth orbit.
We've got a problem. NASA has been literally going around in circles with its space program for the past 30 years.
Astronautical engineer Dr. Robert Zubrin has been arguing for years that sending humans to Mars is the mission the space program needs.
It's time that we set goals for NASA that were worthy of the risks of human spaceflight. Mars is the next logical step in our space program. It's the challenge that's been staring us in the face for the past 30 years. It's the planet that's most likely Earth. It's the planet that has on it the resources needed to support life and therefore someday technological civilization. It's the planet that will provide us with the answer as to whether life is prevalent in the universe or exclusive to the Earth. And it's the planet that will give us the critical test as to whether humanity can break out of the planet of our birth and become a spacefaring species.
In the early 1990s, Zubrin was the head of the Mars Direct program at Martin Marietta Astronautics. His team developed a mission to Mars that could be done at a fraction of NASA's projected costs. Using only existing technology, Zubrin argues that the first steps on Martian soil could be made within 10 years.
There is absolutely nothing in this that is beyond our technology.
We are not ready to send humans to Mars right now. We don't know how to keep them alive. There are people out there who say we can go to Mars tomorrow. One of my requirements, one of NASA's requirements, is that if we send humans to Mars, we bring them back alive.
For the past 15 years, Zubrin and his colleagues have waged a campaign to convince society and the political class that humans on Mars should be the goal for NASA now. This is the story of our cold neighboring planet and the debate over whether man's fate is tied to the red world. It's the story of an engineer's journey and the battle of ideas over which direction in space will truly benefit mankind.
We're at a crossroads today. We either muster the courage to go or we risk the possibility of stagnation and decay.
The victor in this debate could determine the fate of mankind. Will we become a spacefaring species? Will we live on more than one planet? While at Martin in the 1990s, Zubrin and his colleagues developed a plan for sending humans to Mars that changed NASA's thinking on the issue. But the plan has languished on the drawing boards ever since. Now, as president of the Mars Society, Zubrin is at center stage in the debate over the future of manned spaceflight. Known as a smart, visionary scientist, he has authored several books on exploring space and is the self-appointed spokesman for the possibility of colonizing Mars.
Mars is where the future is. Mars is the closest planet to the Earth that has on it all the resources needed to support life and therefore technological civilization. It has water, it has carbon, it has nitrogens, it has a 24-hour day, it has a complex geological history that has created mineral ore, it has sources of geothermal energy. Mars is a place we can settle.
One reason for such optimism over a frozen world like Mars is evidence that 2 billion years ago, Mars was a much warmer and wetter place. In the summer of 1989, the first President Bush announced the Space Exploration Initiative, directing NASA to draw up long-term plans to get humans back to the moon and begin developing a program of manned Mars exploration. NASA assembled a large team to take on the space initiative. In 90 days, the team developed a 30-year plan that required an enormous buildup of space infrastructure.
What the NASA bureaucracy decided to do was basically design the most complex mission they possibly could in order to make sure that everyone's pet technology would remain mission critical, which is the exact opposite of the correct way to do engineering.
First, NASA would triple the size of the planned space station and add enormous hangars, as well as free-floating fuel depots, checkout docks, and cruise stations. Then, on the moon, they would construct more shipbuilding facilities, bases, and depots. Next, the moon crew would construct the Mars ship, a huge craft dubbed by its detractors as Battlestar Galactica. This ship would carry everything to Mars over an 18-month flight. Once in Mars orbit, a small group would descend to the surface, spend a few days, then plant a flag in the ground and go home. The plan became known as the 90-Day Report.
To those of us at Martin who had been engaged in designing Mars missions, when they saw the monstrosity of complexity of the 90-Day Report, we were dismayed, and it was readily apparent to anyone with any insight that that program would fail politically.
The plan was submitted to Congress. The estimated cost, $450 billion. The legislators went into sticker shock. This would have been the single most expensive program for the United States since World War II. By the end of 1990, Congress had refused all requests for SEI funding. When the realization came that SEI was doomed, Zubrin wrote a memo to his colleagues at Martin Marietta, outlining his problems with the NASA plan and arguing for a more direct approach. Zubrin favored launching a Mars mission directly from the surface of Earth, using only existing rocket technology. This negated the need for a lunar base and avoided the complexity and cost of building ships in space. He also objected to NASA's plan for a short surface stay on Mars, a mission that would amount to little more than a flag and footprints exercise. To Zubrin, we were going to Mars to explore and develop a new world. To maximize surface time, Zubrin proposed using a faster flight path, known as a conjunction-class mission. This would mean a crew could arrive on Mars after only a 6-month journey. They would then remain on the Martian surface for a year and a half. This would give the team time to explore a wide area and conduct detailed research about the planet. Then, as the Earth return window opens, the crew would launch from Mars for the 6-month trip home. Zubrin was convinced that a simplified, more robust and cost-effective mission could be designed using these principles. Zubrin and Baker were convinced that a Mars mission could be launched directly from the ground. The other team members felt this was impossible, that the weight of the rocket fuel required for a round trip to Mars was so enormous it would render the launch ship impossibly heavy. To solve this problem, Zubrin was exploring a radical idea that had been kicked around the aerospace industry since the 1970s. The idea was to produce a methane-oxygen rocket fuel directly from the Martian atmosphere. It was a relatively simple and robust chemical engineering procedure that was done commonly in the 1800s, the era of the gaslight. If the idea worked, astronauts could land a relatively light ship with empty tanks. They wouldn't have to ship all the fuel with them for their return trip. This would radically lower their size and weight. The only problem was methane-oxygen fuel requires a hydrogen component. Hydrogen exists on Mars in the form of H2O, but water may be difficult or impossible to extract from the Martian environment.
Really, the hydrogen was only 5% of the total weight of the methane-oxygen propellant being manufactured. So if you just say, okay, we won't be pure, we won't get all of the propellant from Mars, we'll just get 95% of the propellant from Mars. The other 5%, the hydrogen, we'll just bring from Earth.
Another fundamental resource that could be extracted from the Martian environment is oxygen. A second processing unit could separate oxygen molecules from the thin carbon dioxide atmosphere, providing breathable air for a Mars crew.
If used intelligently, the same resources that make Mars interesting are precisely what could make it attainable.
Baker and Zubrin had greatly reduced their mission mass, but they still found their ship was too heavy and would require 2 launches and assembly in space. Then Zubrin hit on an idea.
Well, one of the key events of the Mars Direct development was one morning Bob burst in my office and said, "I've got it."
The idea that I finally hit on in 1989 was that we would split the mission up into 2 parts, and we'd send the return vehicle out first with its own return propellant plant. So the propellant would be made on Mars before the first astronauts ever left Earth.
With 2 separate direct-to-Mars launches, a human crew would have a fully fueled ship waiting for them on the surface of Mars before they ever left Earth. So Zubrin and Baker had come up with a plan that seemed to accomplish all of their goals. It was relatively inexpensive, development time was short, they could use existing technology, and it allowed for a long stay on the Martian surface. They dubbed their idea Mars Direct.
SSC disconnect enable on. 35. Electronics go. Hydraulics go.
Aboard an Ares rocket is the Earth Return Vehicle, or ERV.
Pressurized vehicle lock.
No one is aboard this ship. It will pave the way for the astronauts who, years later, will use the ERV to return to Earth.
1. Liftoff.
On its second day, the ERV deploys a small nuclear power reactor. The reactor powers a chemical plant inside the ERV. The plant will produce the methane-oxygen rocket fuel for the launch home. Nearby, a second robotic rover is guided to a pre-picked landing site for the human crew. It places a radar transponder to help guide the astronauts in. The long journey to land a human being on Mars begins.
3, 2, 1, engine start.
Carrying the most skillfully assembled flight team in history, 4 astronauts begin their 2.5-year mission to the Red Planet. This will be the first time a human has gone beyond the Earth-Moon system, 250 million miles farther than any person has ever been. To counter the health problems of zero gravity and to fully acclimate the astronauts to Mars, the ship will deploy a weighted tether attached to the last stage of the spent rocket booster. By thrusting the ship into a rotational spin, the counterweight of the rocket will create centrifugal force and thus artificial gravity. The crew will be able to live with their feet planted firmly on the floor during their 6-month transit. But the HAB is not entirely alone on its journey. Just ahead of it is a second ERV, identical to the first. Launched just a few weeks prior to the HAB, it will prepare the way for a second human crew that will follow 2 years later. It can also function as a backup for the first mission, if anything should go wrong. On the 6th month of the flight, the crew will gaze upon an alien world. This is the new frontier.
Oh, spectacular. Just spectacular.
After days in orbit and satisfied with the landing conditions, the crew will receive final word from Mission Control on Earth.
All systems are go for entry, descent, and landing. 3, 2, 1.
It will be a tense 40 minutes before people back on Earth get the signal from Mars and know if everything has gone well.
Okay, 75 feet. Car's looking good. Down a half. Pitch forward. 60 seconds. Lights on. Forward. Forward. 40 feet down. 2.5. Straight shadow. 4 forward. Drift into the right a little. 30 seconds. Forward. Contact light. Okay, engine stop.
We're seeing it on the LTP. We're on Mars, everybody.
For more than 500 days, the astronauts will live on Mars and embark on one of the greatest journeys of discovery in the history of science. Will they find life? Or the fossilized remains of past life? Such a discovery could tell us whether our solar system has seen more than one Genesis, and answer the ultimate question: are we alone? In any case, these explorers will be learning how feasible the colonization of Mars really is, and whether or not mankind has a future among the stars. Then, when the time comes and the window for Earth return opens, the crew will climb into their Earth return vehicle and head home. They will arrive home heroes, the first to stretch the limit of man's expanse from one planet to another, their names added to the list of great explorers of new worlds. In their footsteps, others will follow. What began as a trickle is free to rise into a deluge of humankind, sweeping over a once barren land and transforming it into a viable new world. Eventually, with a lot of ingenuity and invention, the scientists will learn to live off the land. They will grow crops in the iron-rich but potassium-poor soil. And they will produce oxygen and energy from the water and atmosphere. Sooner or later, children will be born, the first true Martians. They will grow up to see Mars as their home. With time, more and more people will arrive. These won't only be scientists, but settlers, people who plan to stay. They may come for all kinds of reasons, but to them, Mars will be a chance to start over, to build a new life for themselves.